Okay, question 24. So we've got some 3D trig. So we have some information there, and our task is to calculate the size of the angle between TB and the base ABCD. So first off, we try and figure out where P is. So it says P is a point on AB such that AP to PB is in the ratio of 5 to 2. Okay, so if we kind of place it approximately kind of there, that's going to be point P. And we know it's split in the ratio of 5 to 2. If we turn that into a fraction, it's 5/7 and 2/7. So if we find the distance of AP, AP is going to be equal to 5/7 of the full length of that line, which is from the question 14.7, which makes that 14.7 times by 5/7. We can just stick that in our calculator. That's going to give us 10.5. So we know the length of this is 10.5. Okay. So what we probably want to do is try and identify a triangle. And remember, with 3D trig, we can always do it with a right angle triangle. So if I draw on that line to begin with, I'm thinking the right angle triangle I can go for is going to be like that. Okay. And the angle we're looking for is going to be the angle down there. I always think it's a good idea to draw out a little kind of sketch of the triangle. Okay, that's like our X. We already know some information about this. We already know what MT is, so we know that's 2.3, and we know that's a right angle. So with 3D trig, it's usually the better idea to find out what MP is rather than try and find the hypotenuse. Not always, but often the hypotenuse can be kind of a little bit harder to find than some of the others. So if we think about MP, we've actually got another triangle, MAP, at the bottom. So just kind of draw it down like that. Okay, we know this is the 10.5. I'm going to call my unknown Y like that. Okay, that is PAM. So we're kind of looking down on it. And we know the distance. Do we know the distance of MA? So if we have a look, well, we know the distance of BC. BC and AD are the same. M is the midpoint. So M is going to be, MA is going to be half of DA. DA is 3.8. So that's going to be like 1.9. Now what we can do on here, we can just do some Pythagoras. So we can do 10.5 squared plus 1.9 squared is going to equal y squared. Okay, so y squared is 113.86. And we can just call y, we can just say is equal to the square root of 113.86. We want to try and avoid rounding midway through a calculation. So if we leave it like that, then it's going to be a more exact answer. And that is our MP there. Now we've got two sides and we've got a right angle triangle. We can use some SOHCAHTOA. So if we look what we've got, then 2.3 and 113.36. We've not got the hypotenuse, so that's going to be tan. Okay, so it's going to be tan minus 1 because we're finding out an angle. Opposite over the adjacent, 2.3 over the square root 113.36. And we can just type that into our calculator again. And that's going to give us an answer of 12.189. It asks us for one decimal place, so our answer is going to be 12.2. And then we're finished.